Segundo panel del día y nos metemos ya directamente. El panel que tiene como título Building I40 Applications, Why Connectivity Matters. Lo va a moderar Walter Rodríguez Esquivel, que es director de posgrado de la Universidad Tecnológica Nacional de la Facultad Regional de General Pacheco. Y estará junto a él el doctor Daniel Grossmann, que es profesor Technische, Hochschule Ingolstadt de la Universidad en Alemania.
Hola y bienvenidos a mi presentación. Unfortunately, my Spanish skills don't go any further than that, so I will switch to English now. My name is Daniel Grossmann from the Technische Hochschule Ingolstadt, and I'm very happy to give a presentation on building Industry 4.0 applications and why connectivity matters. Before we start, a few facts about me. Originally, I studied mechanical engineering at the Technische Universität München with a focus on information technology. And so after that, I did my PhD at the chair of information technology, also at the Technische Universität München. And after that, I acted as a global research area coordinator within the ABB corporate research. And since 2013, I'm a professor for computer science and data processing at Technische Hochschule Ingolstadt. And my research topics are information modeling, system architectures for Industry 4.0, cyber-physical systems, and the industrial Internet of Things. And in these areas, I'm also active in both national and international standardization working groups. All right, so let's get started with the one slide that no presentation about Industry 4.0 can miss. I guess you all know this slide very well. I just want to point out that when it comes to building Industry 4.0 applications, cyber-physical systems, or the Internet of Things are implementation architectures to implement such Industry 4.0 applications. So let's look a bit deeper into the Internet of Things. And I brought a picture here about the Internet of Things example from the consumer world. And what we see here is that in the Internet of Things, of course, we have things like smartwatches, for example, or refrigerators, and we need connectivity, so they all provide data or receive data, either wired or wireless, and then this data is being processed in an IoT application, and maybe we have some kind of remote control dashboard that we can use to control our fridge or to see the activity on our smartwatch. So this works very well in consumer markets. So why not just use the same approach and do this for industry? So let's take a look and with a slightly different picture about applying this in an industrial context. And it looks pretty much the same, apart from the fact that our devices now are industrial devices, like, for example, robots or other assets used in industrial manufacturing processes. And of course, we have connectivity. They need to provide data. They are connected to some application logic here visualized in the middle that processes the data and then, for example, shows the data also as dashboards where we can interact with the Industry 4.0 application. So altogether, the industrial Internet of Things has the same ingredients like the consumer industry Internet of Things. But let's take a look a bit deeper how these industrial IoT architectures look like. And I brought one example from the Siemens MindSphere Industry 4.0 architecture. And when you look at different companies, their architectures look all pretty similar. And of course, the starting point is the real world where we have our assets, like again, a robot here, or from process automation assets. So our real world devices that provide us the data in sense of time series or events or any other data. And then the first step in any of these IoT architectures is the data ingestion, processing, and transformation. So the data is ingested into an typically cloud-based backend. And in this backend, this data is being processed. The time series data, the events are processed, are maybe aggregated to further data, and then pushed forward to further data analytics or nowadays machine learning applications. So this is a very typical industrial IoT stack, or also a typical IoT stack as you would see it in a consumer IoT area. So then why not just do this? So let's build an IoT application, an Industry 4.0 application, where we want to connect our assets into this Industry 4.0 application. And our assets could be machines, like here a machine tool, or components such as robots, welding guns, gluing devices, or controllers that control the process of a complete production line, or any other production equipment that we have. So let's just connect it using one of these Industry 4.0 architectures, and we're done. So how hard can it be? Well, in reality, it turns out that the industry is pretty different from the consumer market, because the devices in industry are very heterogeneous. In the consumer market, a smartwatch is a rather simple device, a refrigerator is a rather simple device. So the data that they provide is simple compared to industry applications. And in industry today, our data sources, and I show this by these very different looking plugs here, they all look different from a communication interface side. They all provide different data and different structures with different meaning. So we don't have any commonality, or at least not so much commonality between our components and data sources that we want to connect into our Industry 4.0 application. So what do we do today? Well, some of you may know this pain. What we do today is we build point-to-point adapters. So here we have a data source, and we want to get some data out of the data source. So we program an individual data adapter for our individual machines and components and production lines. And this picture should show that this is a very specific implementation, and also as the picture implies a bit, very often these data adapters are not as robust as you would like them to be. And to make matters even worse, we don't do this for a single machine, but we do this for a lot of assets in our production. So in the end, the picture looks more like this, where we just have a chaos of connections that, if we are honest, nobody really oversees after a few years. So once they have been set up, then the expertise goes away to different projects. So then these connectivities and adapters are not so much well maintained. So there is a big disclaimer then saying, do not touch any of these wires, because if you do, then the system may break. Okay, so, well, it turns out that getting our data into an IoT backend may not be that easy, or it comes with a very high effort. So today in industry, we focus on data exchange. That means a sender provides data, and the sender knows exactly what the meaning of the sent data is. So for example, if we send the data 456, then the sender knows that this is the running production of this specific production job, and he also knows that this time is in minutes and not in seconds. And the receiver of that data needs to know a priori what this data means, including the unit. So he needs to know that this is minutes and not seconds. And this is typically implemented into these applications during the engineering of the application. So today, our elements of the system, they provide data and they consume data, and the senders and the receivers, they are very tightly coupled via their programming, which takes place during engineering. And if we want to have some flexibility, then this comes at the cost of re-engineering or doing some reprogramming to our application. And even worse, I try to point this out with this picture with a lot of wires, because these components are so tightly coupled. If you change one element, you need to apply changes to all the other elements in the system that, for example, consume that data. If you don't, then the data connectivity will break. All right, but you could say this works today, so why should we change anything? And one answer is today we have the automation pyramid. That means we have a hierarchical structure for our automation system, production system. So on the lower level, we have the field devices, then we have the controllers. The controllers are part of our stations, the stations are part of centers, and the centers are part of the enterprise. So we have a layered architecture where every layer has a specific functionality, and we have very specific connections between these layers. And these connections are also very fixed, so they don't change over time. But in Industry 4.0, this is different because here we have a lot more dynamic connectivity. So an asset like a drive here, for example, provides data to a maintenance application at one point in time, but at a later point in time, he might also provide data to a predictive monitoring application. So the connectivity, what data gets sent to which receiver, is a lot more dynamic, and we have a lot more communication like a mesh. So instead of having a hierarchical setup in Industry 4.0, the communication setup will be a lot more dynamical. So the connections between our assets and the applications, they grow, and they may grow or change even during runtime. So if data exchange as we have it today is not enough, well, what is it that we need then? And what we need is we need information instead of data. And let's give a very short and brief definition of what information really means. And if you look up different sources, then information is the knowledge that I, for example, need to have, I need to know about in order to plan my actions so that I reach a defined goal. So it's knowledge to plan actions to reach a goal. And let's give an example to see the difference between data and information. So let's look at data, let's say 15 and 20. So if I just look at these numbers, I can just guess what this means, but I don't really know. Only when I provide the semantics to the data, then I understand what it means. So 15, for example, means these are the minutes that I'm already presenting, and 20 means these are the minutes that I have in total for this presentation. So with this knowledge, I can now take some action, and the action could be that if I want to be on time, if I want to finish on time, then I better hurry up. So data plus semantics, this is what makes up information. And in Industry 4.0, we need to switch from data exchange to exchanging information. So let's talk about how we will connect, or how we connect assets to an I40 application tomorrow, or starting today actually. And we do this based on information, because this information can be understood by the receiver. So the receiver understands the meaning of the data that he receives, and this then means that now the receiver has the knowledge that allows him to take actions to reach its goals. And this is very different to just exchanging data. And the very important point is that this understanding happens at runtime. So new applications can enter the game, new applications or applications can change over time, but because we have, let's say, a common dictionary or a common language, they can understand what is the meaning of the data that they receive, and they know how to process this data. So information exchange is the foundation of Industry 4.0, and we need to go from data exchange to this information exchange. And the way to go there is by defining information models. And information models, they define both the data, and that's very important, the semantics that goes with the data. So, and this is the foundation for Industry 4.0 applications. Now, an information model is a very abstract thing in the first place, but then if we take a look around in industry, then we see that there are implementation technologies around to implement or to define and implement such information models. And in the area of Industry 4.0, one very prominent implementation technology, middleware technology, is OPC Unified Architecture. It's an open middleware technology that allows to define information model, and as the slogan here already implies, this is because OPC UA has the goal to be an industrial interoperability standard. And as you can see by all these logos around, a lot of consortia define information models for their specific domains, and I will pick two examples coming from German initiatives. The first example is the information model for robots. This is defined by the OPC Foundation. This is the organization that does these information models or works together with other organizations to define these information models, and the German VDMA, the Association of the German Machine Builders. And this information model specification defines the structure of a robot, which is called a motion device system in the standard. And this information model also defines common identification information so that an Industry 4.0 application can easily identify a single robot. But of course, it goes a lot further because it contains information to monitor a robot with its axes, powertrains, and a lot more internal components like the software running on the robot and so on. And this and it also contains status information, so to see what is the current health status of a robot, and in addition process data such as the current positions of axis, speeds, and load, etc. And this data can be consumed and monitored in an Industry 4.0 application to then create further knowledge and derive actions out of it. And the really important topic here is that Industry 4.0 applications now can get this information independent of the concrete manufacturer of this robot or of the robots, or even if you have different robot manufacturers, you can now get this information independent of the manufacturer. And this means that you no longer need these point-to-point data adapters that you need to program for manufacturer A and for manufacturer B, and which just make the effort for implementing the data connectivity, make this effort increase enormously. So now we have a very simple way to connect our assets to the Industry 4.0 applications. Let's pick another example, and this is about the machine tools. Machine tools are very complex systems, and nowadays, or up to today, all the machine tool vendors have own interfaces, own specifications of data that they provide with own protocols. So it's very much effort to attach a machine tool to an Industry 4.0 application. And also here we have a common information model that was defined by the OPC Foundation together with the German Association of Machine Tool Manufacturers. And it's again defining this time of a machine tool. It again contains identification information, but then of course more detailed information about the machine tool itself, the channels of the machine tool, the tools that it's currently using, the programs that it's running, and status information. For example, things like what is the current production job that is being processed, what is the status of completion, so how long does it take for this job to finish, and a lot more. And again, the key is that now if you have several machine tools from several vendors in your production, you can use this information model, and this makes you independent of the machine tool manufacturer, and also independent of the protocol that's being used. So it again reduces greatly the effort of connecting your asset to your Industry 4.0 application. So in other words, if we want to connect our machines and components, line controllers, whatever, further equipment into our Industry 4.0 application, we can use normal IoT architectures, middleware to do this, but the real point that makes this effort, or that reduces this effort a lot, is that once we have information models, we can easily connect our components and machines into our Industry 4.0 application. And this really greatly reduces the effort, and this is why connectivity matters a lot when you want to build an Industry 4.0 application. And the key for connectivity is that information models provide this on a standard basis, and this means that we can resolve or reduce the effort for building these point-to-point communications between machines, components, other controllers, and our Industry 4.0 application. All right, so coming to the end of my presentation, what's my conclusion and maybe also your conclusion? Building an IoT-based Industry 4.0 application looks easy when you look at it from a high level. So when you know what is the purpose, what's the use case of this application, and you know what data you need to feed into your application so that you can run your business logic, this is rather simple. You can use already existing IoT architectures to do this. You can use cloud services. So this is typically not the real big deal. But the data sources in industry, and this is different to the consumer market, these data sources, machines, automation controllers, and so on, they are very heterogeneous today, and they provide very heterogeneous data with very heterogeneous interfaces and protocols. So currently, we're lacking standardization here, and this in reality means that projects often fail at the point when it comes to connecting the Industry 4.0 application to the data source, to the machine, because then it turns out that the machine doesn't provide the necessary data, or it's just too much effort to implement all these various data connectors. So either, or very often, projects fail, or you need to spend an enormous effort to get the data out of your heterogeneous assets that you have in production. And here, information models can help a lot because they provide a common structure and semantics for data for different domains. And I showed two examples of the robotic and the machine tool domain. And with that, information models are essential for seamless connectivity. So if you want to get rid of this picture with the hundreds of wires, meaning hundreds of specific implemented data connectors, if you want to get rid of this picture, then information models are the way to go because they provide standard language for connectivity, where we can also understand the meaning of the data. So information models are the basis for Industry 4.0 connectivity, and this is why I wanted to give you a short insight about what is the information, the motivation behind information models, and why you should look into information models to make your life easier in future when you want to build an Industry 4.0 application. Because building the back end of this application, this is typically very simple, or this is not the big deal, but very often the big deal is to really connect the machines and data out of your machines and out of your equipment. All right, so this is the end of my presentation on building Industry 4.0 applications and why connectivity matters if you want to do this. I hope you got some insight into the motivation of using and defining information models, and I'm happy to hear and to answer your questions in a second.
Dr. Daniel Grossmann, good morning, and thank you for your presentation. My name is Walter, and he is Pablo. Good morning.
Good morning, how are you? Daniel, thank you very much for your clear presentation. all the concepts that you explained were really clear. You show some information about cloud connectivity, about connectivity to drives, to any robot that we see in the presentation, and we see an example of Mindfield that was really clear. I want to make you some questions to you regarding to what you recommend. Here in Argentina, you know, we are trying to implement all this technology. If you are, all the people, all the owner of the company, the leads, can take this possibility to implement this technology that you show. What is your recommendation to them if they are here to you, and what is your recommendation just to implement this technology here in Argentina in many factories that they are fair to implement this?
Create a new production line, or when you want to purchase new equipment, that you ask your machine vendors to provide information models. So currently, or my experience is that very often the focus is on the functionality of the machine, of the production equipment, which is of course the first place because you want to produce something. But then with the focus on the functionality, there is not so much focus on what is the interface that the machine should provide from it for its IT connectivity. And as mentioned, the OPC Unified Architecture as a technology is currently gaining more and more momentum. So it's available in a lot of machines already today. So my recommendation is when you plan to purchase a new machine, or when you plan to set up a new production line, then ask your supplier to provide this information modeling interface, because this will solve, or this will reduce your effort then greatly when you want to connect your machine and get information for further processing out of the machine.
Daniel Grossmann, thank you for all, and good morning. Bye-bye.
Thank you. I hope you enjoy your Congress, and I was very happy to be here, and I wish you good luck for today and for the next day. So, bye.
Thank you so much. Bye-bye.
Thank you.